any single object or along with that anything is combined, then that combination is called as a item set. If a item or a item set is infrequent, then their subsets which are formed will be infrequent. Transaction database, as the name itself says, we keep a database of the transaction items. The a priori needs multiple scans, but the FP growth, it just takes 2 scans. Hello everyone, I welcome you all to the 4th session of Unit 2, that's under Fundamentals of Data Science. And so this session is all about understanding regarding mining frequent patterns. Over here, my name is Deepa Kutnikar. I am working as an assistant professor in the Department of Computer Science, Vidhyaashram, Temple of Excellence, Mysuru. In our previous session, that's under session 3, we have discussed like what is data reduction as well as data transformation. And in today's session, we will be discussing regarding mining frequent patterns. Alright, let's start our session. Let's see a quick introduction with respect to mining frequent patterns. Yes, this mining frequent pattern is a type of data mining technique, and over here, as the name itself says, it is used to mine the frequently repeated patterns, or in a simple words, we can say that or consider that it is used to discover the patterns that is usually repeated frequently in a larger data sets. So this is all about mining frequent patterns. Now let's understand where is it applied. Yes, these patterns are applied in market basket analysis as well as in decision makings. Yes, absolutely, we need that patterns in order to take decisions, right? We can't directly see the raw data and take the decision. So if our information is represented in a pattern format, then it will be very easy to predict like what will be the decision, or also we can analyze the market basket analysis. Along with that, this frequent mining patterns is also used to find the association correlations as well as the various structures that occur during mining. So this is a basic introduction with respect to mining frequent patterns. Let me again brief that this mining frequent patterns is none other than just extracting the frequently repeated information or the data from a larger data sets, and this is used in exactly the market basket analysis as well as in order to find the association correlations as well as structures of the informations. As we did understood that there will be patterns, now we have to understand like how these patterns are defined. So let's move ahead and understand this pattern using some basic concepts. The first concept that is utilized under mining frequent concept is a item. So this item includes a single attribute, or we can also consider an object in a data sets, and the examples are like milk, bread, butter, etc. So these are various objects that are considered. The next concept is an item set. First, the item, yes, we got to understand that a single object is called as an item. Next, what is this item set? Item set is a collection of one or more items. For example, here we did consider milk, bread, butter, correct? So these are single objects. Here, any single object or along with that anything is combined, then that combination is called as an item set. So let's see an example here, milk. So the object is 1 and it is termed as an item set. Further, the combination like milk, bread, and the number of objects are 2, it can be considered as second item set. Similarly, I have next combination of milk, bread, butter, and it has or it consists of 3 objects and it is considered as a third item set. So this is an example for item as well as a item set. The next concept is a transaction. A transaction is a set of items that is bought together or which is occurring together. So let's say example for transaction. If we consider the transaction ID and the item, then we can just describe it in this way using a table where the item ID is T1 followed by the item purchased is milk as well as bread. Then the second transaction is of purchasing of milk with butter, and the third transaction can be buying or purchasing or occurring of objects of milk, bread, butter. So this is how a table form is created and it can be called as a transaction. So these are the basic three concepts. Let's move forward and understand the next concept. Yes, the next concept is transaction database. Transaction database, as the name itself says, we keep a database of the transaction items. The example is like T1, we can consider it as milk bread followed by T2 milk butter, and T3 can be considered as milk bread butter. This is very similar to as that of the transaction example what we saw in our previous slide. Now the next concept is a support. The support concept measures that how frequently an item set is appeared in that database. Let's see a simple formula for the support, that is support of item set, which is equal to number of transactions containing the item sets divided by total transactions. So this is a support. So we can note here the upper thing is that the frequent appearing of a item set followed by total number of items present in that databases. So this is our next concept. The next concept is a frequent item set and infrequent item set. So let's see what is the difference between frequent as well as infrequent. But as a basic thing we know or we can just understand by reading the heading. Frequent means there will be usually mostly repeated frequent patterns, and infrequent means very leastly repeated item sets. An item set is called as frequent if and only if its support is greater than or equal to minimum support, that is greater than or equal to the minimum support. Let's say an example here, the minimum support we are targeting or considering is 50%. Okay, so this should be a minimum support. So support, let's recall what it is. Support is nothing but an item set which is frequently repeated. Okay, so that is nothing but a support, and with respect to this we are considering the minimum support as 50%. Up next, the next item sets that we have considered, that is milk. Okay, milk, it is repeated with other forms or other items, so we can consider it as mostly repeated and it is greater than our minimum support, that is 50%, greater than 50%, correct? Because it is mostly repeated item, thus we are considering it as a 100%. The next combination of item set or the next item set is a bread. And with respect to bread, the support what we can consider is of 2/3, which is nothing but 66%. Yes, how this 2/3 is generated is, let's get back to our previous slide to understand this. We have considered this combination of milk, bread, milk, butter, milk, bread, butter. So here we can just see mostly repeated item is a milk. So for this milk combination, what is the support we have considered? 100%. Okay. How is it? Because it is frequently supported or frequently repeated. Next is a bread. So let's get back to that example. Here we can see out of these three, the bread is present in 2 of the item sets, correct? The bread is present in 2 of the item set. So the combination is 2/3. And the 2/3, what is this 3? 3 gives a total number of item sets. Thus, 2/3 gives us a value of 66% and it is a frequent. It means that it is greater than minimum support. Up next, let's consider this butter. Okay, let's get back to this example, and here as we can observe, the butter is also present in 2 of this combination, that is a T2 and T3. has this is present in T2 and T3 and the total number of combinations are 3. Thus, we can consider this as a 2 by 3. The support is considered as 2 by 3 and the percentage, if we calculate, then we get it has a 66%. Thus, we can say yes, even it is frequently repeated. Thus, it is considered under frequent item set. Okay, so this is a concept under a minimum frequent patterns. So don't be confused, support is just nothing but an item set which is frequently repeated. And now with respect to frequent item set, we did understood how the frequent pattern is considered. Firstly, we will fix the minimum frequent support value. So we have considered it has 50%. And up next, with respect to the example, we have defined the support for each and every item set. So this is how we will be understanding or calculating the frequent item set. Let's move forward and understand the infrequent item sets. So this comes a complete opposite of the first, that is frequent item set. Here what happens is the leastly supported item sets are considered. Thus, let's see and understand this through an example. The first item set what we are considering here is a bread butter combination. The bread butter combination, let's get back and see bread and butter combination. Is it present in first T1? No. Is it bread butter combination is present in our second transaction? No. Bread butter is present only in my third transaction, right? Okay, let's calculate the support for this. That is 1 divided by the total number of transactions or the item sets, that is 3 item sets, correct? 1 by 3 gives us a value of 33, for which the minimum support what we have considered is 50%. But this is below 50% and thus it forms an example for a infrequent item set. Is it clear the difference between frequent item set as well as infrequent item set? It is very, very easy. Up next, let's head up with the next concept, that is frequent patterns, on which a complete chapter is dependent. So let's understand this mining patterns in a very good way. Let's understand how these frequent patterns are defined or declared. A frequent pattern can be of a frequent item set or a frequent sequence or a frequent substructure. Let's see an example for this, a milk bread. Yes. So this is a frequent pattern if it appears often and often. Thus, we can consider the support, correct? What does support means? If an item set is repeated or frequently appeared, then that is considered as a support, correct? Yes. If any of the item set supports is good, then we can consider it has a frequent pattern. The next concept is association rules. As usual, the association rule gives us a relation between the item sets. Let's see the rule format, that is X tends to Y, followed by the example like we have considered milk, bread, butter, right? Thus, we have considered one of it, that is milk tends to bread. So, milk is considered as one of item and the bread is considered as one of item, and thus a association rule gives a relation between a milk and bread. So you can understand this in one more way, that the bread preparation requires a milk as a raw ingredient. Okay, so this is nothing but a association rule. The next concept is confidence. Confidence, as we have our confidence levels, in the same way there should be some confidence for the frequent patterns, and if and only if the association rules holds good, then we can say that the item set is confident. Let's see an example for this. Confidence of X tends to Y followed by support X union of Y divided by support of X. So this is a smallest consideration with respect to support as well as a confidence. So this was the formula, and let's see an example here. Support of milk in that previous example. Do we remember that? Yes. The milk appeared in all the 3 transactions. So we are considering 3. Next, support of milk, bread. So the milk and bread is repeated how many times? Let's get back and see. Milk and bread is repeated 2 times, correct? Milk bread combination, that is in T1 and 3 transactions. So we have considered support of milk, bread has 2. Next, let's go forward with confidence of milk is to bread. So what is the value? That is 2. First and second, right? 2 by 3, which gives us a value 66% with respect to percentage. So this is how we can understand the concept of confidence easily. The next concept is lift. The lift is used to measure the strength of a rule compared to the random occurrences. So let's see an interpretation with respect to lift. Consider that if a lift is greater than 1, then we can consider it has a strong association. And if lift is equal to 1, then we can consider it has no association. And if it is less than 1, then we can consider it has a weak association. So this is next concept after confidence, which gives us a further measure of strength with respect to item set, with respect to the association rules. Let's move forward. Now let's see a simple example of frequent patterns that we use in our day-to-day life frequently. So it's none other than a milk, bread, butter as well as egg combination. Also, as a student, we will consider or utilize a book as well as a written pen or pencil and a eraser. So these are the frequent item sets that we utilize in our day-to-day life, correct? So this is just a small example. Now let's move forward and understand various principles or the algorithms that we can apply with respect to mining frequent patterns. As we did understood various concepts that are included under these patterns, now let's move ahead and understand what are the basic principles or the algorithms. So these are very, very important, the algorithms with respect to your exam point of view or your IE point of view. Okay, so let's understand what are the various principles or algorithms that are available. The first algorithm is none other than a priori algorithm. Second one is the FP growth algorithm. So these are the 2 prominent algorithms. Now, what is the aim of both of this algorithm? These both algorithms will aim to find the frequent item combinations. What is its aim? To find the frequent item combinations. Thus, these are the very frequent algorithms. Let's move forward with the initial algorithm, which is nothing but a priori algorithm. So this is also called as breadth first search algorithm, which uses the candidate generation as well as pruning techniques. Now, candidate generation, yes, we can understand that by name, but what is this pruning? Pruning is a simple technique of removing the non-essential branches or what we can say unessential candidates from that combination. Okay, and this removal is completely dependent on the a priori principle. So what is this a priori principle? Let's move forward and understand that in a better way. The a priori principle states that if any of an item is frequent or it is repeated, then all of its subsets will also be frequent, and conversely, if any of an item is not frequent, then their subsets will also should be infrequent. So let's consider an example here. So we have this decision tree, but now let's consider one more example. For example, we have various items. For example, A will be one of an item, next B will one more item, next C is the next item, as well as D forms a next item here. So items are A, B, C, D. Now, if we consider that any of an item is repeated frequently, then their subsets form. Subsets in the sense, for example, the next step will be A with B. Yes, this is a subset. Then again A with C. So this forms one more subset. Again A with D. So this is the third subset that is formed. Correct? A with C and A with D. If we consider that A is frequently repeated or A is frequent, then their subsets formed will also be frequent. And now let's consider that C is not frequent. Then their subsets which will form will also be infrequent. So that is a simple a priori principle. Okay, so you can write it in a straight way or a direct way, that if an item set or an item is frequent, then their subsets form will also be frequent. Conversely, if a item or an item set is infrequent, then their subsets which are formed will also be infrequent. So this is a very simple principle, and by using this principle, what we can expect is the unwanted or infrequent patterns can be pruned or removed or eliminated easily. Correct, right? So when we have frequent patterns, our goal is to only consider the frequent patterns, because those are the patterns which we can group as frequent patterns, and the infrequent patterns which we are not supposed to utilize that in our operation. So those subsets or those items will be eliminated or pruned. So this is a simple a priori principle. Now let's move forward, as we did understand what is the basic concept and the principle. Now in the next thing, we will be understanding what are the steps that is included in a priori algorithm. The first step, as we know, we will be generating frequency, correct? That is first item set. Next, we will be generating its subset, which we can call it as the second item sets. And the third step will be the infrequent items which are available will be pruned or eliminated. What is the next step? The next step is we have to continue writing that subset format until no new item set is formed. For example, let's get back with respect to this. With respect to this is a first item set, okay? And its subset that is formed, that is AB, AC, then AD will be the next frequent patterns, or we can call it as second item set. What's next? We have to eliminate the infrequent patterns. For example, here the C and D are the infrequent items, so we can prune it out. So that is our third step. What is our first step? To generate frequent item set. The second step is to generate candidate, that is generating subsets, which is none other than AB, AC, AD. What is the third step? To eliminate or prune out the infrequent items. Okay, that's done. What is the next step? We have to verify that our subset is completed. If not, we have to complete it out. Have we completed here AB, AC, AD? Yes, there is no other item to continue. So we are done. So these are the various steps that we have to undergo. Let's move forward and understand finally like what is the advantage and disadvantage of a priori algorithm. Advantage is none other than it is very simple and easy to understand. Correct, right? It is very simple. We have to just see which are the frequent items and we have to form a candidate or a subset. Then we have to prune out the unwanted items from that data set. Up next, thus we have to verify finally that our candidates that we have generated is completed. If not, we have to complete it out. Okay, so these are the 4 different steps. Thus we can say that this a priori algorithm is simple and easy to understand. And the main thing, it uses pruning or eliminating to remove the unwanted search spaces. The disadvantage is it has to scan the multiple databases or data sets. Then the computational cost to scan is very high. Thus, these two forms the disadvantage. Alright, so we have completely understood this a priori algorithm. Let's move forward with the next type of algorithm, which is utilized to find the mining frequent patterns, which is none other than FP growth algorithm. So let's understand the basic concept of FP growth algorithm. Yes, this is also a one of frequent pattern technique. Here, it avoids the candidate generation as well as uses the FP structure. Instead of candidate generation, it uses the tree structures. The working step involves that this algorithm scans the database to find the frequent patterns or frequent items. Then the second step is none other than building a FP tree. So FP tree is nothing but frequent pattern tree, which includes a root node, and followed by there will be a creation of header table. Then we do have to create the next following node link values or the items. So yes, here we form a FP tree, that is frequent pattern tree, based on the scanning of the frequent item sets. So that forms our second step. The next step is generating frequent patterns using divide and conquer rule or method. Please note, this is very, very important. We will be utilizing divide and conquer concept to form a FP tree. So this is a complete steps that is involved with respect to FP growth. Up next, let's see what is the advantage as well as disadvantages of FP growth. The advantages is absolutely it is very, very faster compared to a priori, as initially itself it scans the frequent patterns and then it follows the next step of building that FP tree. The next advantage is only 2 database scans. So yes, the scanning happens twice, and this type of algorithm is a best match for a large data sets. Coming with a disadvantage, implementation will be complex, as we have to go with a tree, that is FP tree, which will be built based on divide and conquer method, and the construction of that tree includes various steps and it is complex as well as difficult too. So this is an advantage and disadvantage of FP growth algorithm. Let's move forward and see a small comparison between a priori and FP growth algorithms. A priori, as we know, it generates candidates, and with respect to FP growth, it does not generate any of a candidate. Instead of candidate, what does it generate? It generates the trees. And with respect to scan, the a priori needs multiple scans, but the FP growth, it just takes 2 scans. That's it. With respect to efficiency, yes, definitely the FP growth is more efficient compared to a priori. Alright, let's head up with the next concept, which is nothing but mining association rules. The association rule mining is used to find the relationship between the items, and the items we can consider as X and Y as the item sets, and the relation that we can define as X tends to Y. Let's head up with the next, that is measuring of this association rule mining. So how to measure this? As we know, we have understood various basic concepts of mining frequent patterns. So let's utilize that, correct? Yes. Come, let's understand that measures of association rule mining. The first thing is a support. Support, we know that it is utilized in order to represent the frequent pattern or frequent items. With respect to this, it is utilized to give the frequency of use. The second concept is confidence, which shows the reliability of the rule. The next concept is lift, which depicts the strength of association. So yes, with respect to these concepts, we can easily measure the association rule. As we did saw the various steps that is involved in a priori and FP growth, let's see what are the steps that is included under this association rule mining. The first step is none other than finding frequent item sets, then generating the association rules with respect to them, followed by applying minimum support and confidence to that item set. So these are the steps that is involved in association rule mining. Alright, now let's see the example of this association rule mining. Yes, absolutely, it can be used in a market basket analysis. Application includes that this association rule mining can be included for market basket analysis, for web usage mining, as well as in fraud detection, as well as with respect to recommendation systems. So these are the applications of mining frequent patterns. Yes, this is all about today's session. Thank you.